So, important things that you notice when you were reading the problem. I'll take anything from anybody. Important things that you notice that drew your attention, Victoria.
Strictly increasing.
Strictly increasing, what does that mean?
That, I'm just gonna go with brackets.
Okay, you're thinking brackets. Strictly increasing. If I asked you guys to draw something for me that was strictly increasing, what would you do? Right, we'd probably do something like really like strong. It doesn't mean in a line, it just means increasing without ever decreasing or flattening out. The graph would look something like this. Other things that you saw that seem important.
Differentiable.
Twice differentiable. Okay, you guys know exactly what differentiable means. Differentiable means W prime exists, right?
Yes.
Twice differentiable?
W prime.
W prime also exists. What else? Other things that you noticed that seem important. Brian, what else?
If T equals 0, the temperature of the water is 55.
Okay, and we have a name for that, right? Temperature of the water at time 0 is 55 degrees.
Initial condition.
That's your initial condition.
Time starts at 30 minutes.
Okay, we've got this domain restriction of 0 to 20, and the water is heated for 30 minutes. The other classes thought I made some sort of a typo. No, that is deliberate. That is deliberate. Where I haven't seen much success today is with part A.
Yeah, that confused us too, but then we caught on.
Okay, what did you catch on to?
That we could use the first theorem of calculus.
The fundamental theorem of calculus. That's what this guy over here is. Right, the fundamental theorem says that the final value equals the initial plus the total change. This is your total change. Another thing that you could do, and I saw some success with the AB students today, stick with me. What does W represent? W, not W prime. W represents
Temperature.
the temperature. W prime represents
The rate of
the change. It is specifically what I would want to hear is how fast the temperature changes. If W prime is how fast, I'm not even sure anymore if that's spelled correctly, who cares? Then the definite integral has to represent how much it changes. Okay, so it's a question of how much. So you're going to say W of 20 minus W of 0, W of 20, 71, W of 0, 55. Shame on you if you told me it's 16. Because nobody cares. No one actually cares, Nathan, that 71 minus 55 is 16. Nathan, why don't I actually care that 71 minus 55 is 16?
It's free response.
It's the free response. And on the free response, we don't care about simplifying.
16 degrees.
All you can do, the only thing you can do is throw away a point here. 71 minus 55, you have the point. You mistakenly call it 26. I will be there to take your point away. Just know it. All right, 16 degrees Fahrenheit. What's the significance of the 16 degrees Fahrenheit, Anthony?
From T equals 0 to T equals 20 minutes. The
From
temperature
T equals 0 to T equals what?
20 minutes.
20 minutes.
The temperature of the water increases by 16 degrees Fahrenheit.
The temperature increased by 16 degrees Fahrenheit. Is everybody okay?
yeah.
Good. All right, part B, definite integral from 1 to 20, 0 to 20, whatever. There we go. They tell you left endpoint method. This is a good thing. What I'm seeing on most papers is, let's see, so we're going to have what, 4 times 55. Are we okay with that? Brian?
It says W of T.
W of T, thank you very much.
I have a question.
Yep.
This is four
No, we started with
4
zero.
sub-intervals, but
Yeah.
it's from 0 to 20. What did that be? Wouldn't the width be 5?
Great question. I'm glad you asked that question. We're going from 0 to 20. How many rectangles?
4.
4.
4. How wide is each rectangle?
Depends
The same.
It's not the same.
How wide is each rectangle? Read the question again.
Oh, it just says 4.
It just says 4. At no point does it say 4 of equal width.
That means
This is the thing. So when you do your partitioning of the interval and you say, oh, I'm going to go from 0 to 20, I know what we used to, I'd say like 4 of equal width, and 20 minutes to 45, and cha-cha-cha. You have to make the cuts at the only places where you know the values. So 0, 4, 9, 15, and 20. And then we say, okay, how wide is the first one? 4. How tall? 55. How wide is the second one? 5. 5. How tall? 57.1. How wide's the third one? 6. How tall? How wide's the fourth one? 5. How tall? What is it, 67.9?
Is this a calculator active? So
The whole question is calculator active.
okay.
And if you write that, I'm there to take your point away again.
Good.
Okay, hold on.
So mean.
I know. It's exactly what Caroline says tonight, and I say, too bad. Move out. Why is this wrong? Why, oh why am I going to take the point away, Jose?
You forgot the 1 over 20.
I forgot the 1 over 20. You are telling me that this expression over here on the left is equal to this expression over here on the right? Not equal to each other. You want to make them equal to each other? Put that 1 over 20. And put the parentheses. The other thing that, God, we've got to avoid. I don't even want you guys to look at it for too long. Okay? Take a look. Look away. Stop looking. What's wrong? What's-
Didn't
What's-
he just solve this?
What's wrong with what's right up there?
Is this giving you the antiderivative?
This is saying go find an antiderivative.
I know
You
that.
have already done that work over there. Oh my God, all the students who think that that actually is something. It's nonsense. Don't write it.
Isn't it
Yeah.
approximately not equal?
And even better is the approximate. Now that's the place where the College Board's going to be forgiving between equal and approximate.
Except for you.
Okay, except for, no, I'll be forgiving as well. Now, what's that number?
We don't
Something.
care.
I don't care. You're wasting time if you tell me what the number is.
But add all the numbers.
Right? The number, it's going to be like 60.790, I think. And if any of you actually know it, shame on you, wasting time. Okay. So 1 point for like the form, and then there's another point if that actually is the right numerical value. But there's a third point, and you need to know what the third point's for.
If it's over.
That's a-
Is this an overestimate or is this an underestimate? How many guys for underestimate? 1, 2. How many for overestimate? How many guys have no idea, to be honest? Okay, thank you for the honesty. How are we going to figure this out?
Find the
Left
first row.
and is.
Not the first derivative.
Second one.
It's a
5
picture.
to 71.
You're thinking about the picture. Tell me more about the picture.
Well, it'll be increasing or it doesn't matter, but you're
If
starting
it's
with the
concave
left.
up or concave down.
Right?
Yeah.
If you plotted the points, the graph looks like that. So what do we know?
So is it under?
Under.
Yeah, okay.
Underestimate. Why?
Because
Concrete,
to the
yeah.
left endpoint, you start, and the graph is increasing.
That's the piece. They told you increasing for a reason. If W is strictly increasing, the only way to get from here to here to here to here is if those Y values are constantly increasing. If they hadn't told you increasing, could the graph do that?
Yeah.
And that would be a problem. Your graph could do that, and then the left endpoint wouldn't give you underestimate. So I'd say underestimate because W of t is increasing and using the left endpoint method. Okay. You guys good?
Yeah.
Okay, 5 more minutes for part C and D. Roger, go drink some water, come back in 5 minutes.
Don't die.
Don't shut the camera off. So Victoria, Miss Needham just emailed me and said you have Nathan's homework.
You gotta give it to him.
Okay. She also said that Jose is staying after school for detention instead of Nathan.
What?
Okay, maybe that was a lie.
Well, she said yeah. She said it's true.
What? Is that true or not?
It's a
Oh,
lie.
Okay, man, say. Keep saying it's good to it. What?
Oh.
Oh, I'm sorry.
Chepa has a life.
My equipment is expired.
So sad and all the stuff is covered.
What are you doing, bro?
I don't know, don't we use
This calculator, right, so we just, okay.
That's what I thought, but
20 to 25?
I did W
Because
40 plus
this-
definite
there's only
20 to 30
functions.
W prime.
What did that work?
I was supposed to find the answer. No, answer.
Is the integral of W
Yeah,
prime
that's
t
what
will
I
give us
thought.
the changes?
Yeah.
You can just add the W 20.
So you're trying to find v of t.
Oh, it's from 20 to 25, not 30. Right?
So you're supposed to find that derivative.
Yeah, you can just-
Few days of the before the end of school.
Are we supposed to know the derivative?
No, answer derivative.
Yeah. How you gonna go WT if you already did W prime?
The big name.
And the derivative of W?
Prime with T.
Yeah.
Negative.
Because you also have to focus on the other.
I'll
That's
count
a,
it.
that's the word about this function.
You know,
Substitution.
Because you have to add in the initial function when you back before.
Oh,
Wait,
yeah,
you
you're right.
So this function and this
What?
function.
Usually calculate like everything.
Yeah.
yeah, he said Mr. D said it was hard.
It's not gonna hold.
Wait, are we allowed to use our calculators right now?
The whole thing is calculator.
I could use my calculator.
The whole thing is calculator.
I'm not gonna use it either.
So this is inactive, it will get,
Calculator.
if this is inactive, this is just be the only question.
You guys won't be able to do it.
Oh, forgot I got you. Yeah. What is grading?
Grading.
No, grading.
I don't know why. What is this word called again?
Check it. Lucio,
So can you keep these?
Brian. Yes, I'm fine with you guys.
Oh,
Put them on my hand.
I'm gonna want these back though.
The molders or?
No, all the stuff. After the exam, so I can give it back to you before the BC exam.
Oh, I was gonna
It
put
is
it in my
very
bag.
likely my organizational systems are superior to anything you have out there.
Oh, but I'm super
Some
organized.
other person has better opinion.
I look forward to meeting the person.
I'm 6, 7, 8. Yes, that's fine. We have no idea what's gonna find.
Lucio, how do you feel about driving my laptop?
I might actually do.
Pretty good.
Okay. Alright, if you wouldn't mind heading back there.
Except an idea.
Alright, part C. Part C, they wanna know the temperature of the water at time 25, and they told you, is it 0.4 square root of t cosine 0.06 t, is that what it is?
Yes.
yeah.
Okay. How are we gonna find the temperature of the water at time 25? Victoria, what are you gonna do?
The fundamental period.
Yeah.
Okay, so what's your setup with the fundamental thermocalculus?
W 25 equals W 0 plus the definite integral from 20 to 25 of W prime
Oh, that's what
T dt plus 0 to, yeah, the definite integral of 0 to 20 of W prime T dt.
Okay. Okay. Friends over here, what are the thoughts? What do you think? Okay, so you guys are saying W of 25 equals W of 20 plus the integral from 20 to 25 W prime of t dt?
Yes.
Okay. Who's right?
Us.
Lucio.
Lucio, no.
Don't just give in because he's usually right.
No. Lucio, no.
This was nowhere on my radar screen. Nowhere at all on my radar screen.
Which one, the one?
I was hoping this is what was on your respective radar screens.
Oh,
Yes.
Yay!
Okay, you guys are not wrong. Stay with me though. The significance of the 20 is that this function only starts representing the derivative, and only starts representing the rate at time t equals 20. So that's why you can only use this w prime of t from 20 to 25. And so then you'd say, oh, I know the temperature at time 20, is it 71?
Yeah.
So the temperature at time 25 is 71 degrees plus how the temperature changed from 20 to 25. Now you guys have to be really clever about this. You're saying it's the temperature at time 0, which is, what was it, 55?
Yeah.
Plus how much the temperature changed from 20 to 25, plus this guy over here. Do we know what this guy over here is?
Yeah.
What is it?
It's 16.
It's 16, right? So we already kind of evaluated this and said that's 16. So it's the 55
Oh, I see what they did.
plus that initial change that we did in part A added on to this new change.
So
Yeah.
Would it still be the same? thing?
Yeah.
Absolutely would still work. Would still work. Now, the big mistake, let me show you the big mistake that was made last year and see if you guys can have a quick conversation about why this is the big mistake.
Oh,
Oh,
So don't talk to me, talk to your neighbor. Why is
the
that wrong?
domain restriction.
Why is that wrong,
yeah.
Victoria?
It's
Because
20.
in part C we told you that
Can you start graphing the function on the calculator?
it gives you a restriction from 20 to 30,
Yep.
which means that you can't go straight from 0 to 25.
Yeah, close that out. Right, if w prime of t is only defined from 20 to 30, you can only start using this guy at 20, not at 0, so that's the problem. Now, strange thing, oh God, it was so bad. The number of the friends that tried this, they said, okay, 0.4 square root of t cosine 0.06 t dt. Oh my God, the number of teenagers who actually tried to find the antiderivative. Can you, first of all, none of you all, myself included, could actually evaluate this antiderivative. It is not within our skill set. But they tried, they were like, oh, 0.4 times 2/3 t to the 3/2 times 1 over 0.06 sine of 0.06 t. Because they're totally missing the fact that this is multiplication, and that's not ever going to be an easy problem in the calculus step. You can't just break it up over multiplication. All right, part D. Here's the last one. You guys should expect a problem like this. It has to be on the test. If it's not, I wrote a bad test. For the time interval 20 to 30, at what time does the temperature of the water in the tub reach its maximum temperature? What's the strategy here? Okay, it's the extreme value theorem. Tell me more about that.
It's a relative max. Oh, you have to fancy it.
Right, I need an absolute max on the time interval 20 to 30. I think you guys know exactly what to do. What are we going to do?
Candidates.
We look for a candidate or candidates and
Endpoint.
endpoints. The endpoints are always easy. You are given the endpoints. The endpoints are going to be t equals 20 and t equals 30. Okay. But the candidate, that's going to be, the candidate, there's a lot of folks that don't really understand what the candidate is. If I'm looking for a W has an absolute max, then the candidate is the relative max. So Nathan, if W has a relative max, how would you find that? If W has a relative max, what are you really looking for in your candidate? You're looking at the first derivative. Tell me about that first derivative. What specifically are you looking for?
From t equals 0.
Not when it's equal to 0. That's too generic for me. If W has a max, or even the pointy kind, W prime, be specific though, Nathan. Changes how?
From positive to negative.
Positive to negative. And so you've got it on your calculator. Lucio's back there. And so it's like what, 26.180, I think? Or 26.1799. Somewhere in that neighborhood's fine. Okay. Probably a good idea to go ahead and store that. And the most successful thing that I've seen any of our calculus teachers do, they say, let me make a table here. Here's 20, here's 30, here's my value of A. Those are the times that I'm interested in.
So that would be the work.
And like, this is the work. What goes in this column is like, what's the temperature at each of these times? So let's do it. Temperature at time 20?
71, right?
The temperature at time 20? You should know it.
0.
71.
71. You got it from the table. Okay, you're going rogue back there. Escape. Escape. Okay, menu. Calculus, numerical integral. There you go.
Casino wants to do.
Okay, temperature at time 30. Not in the table. Can't get it from the graph.
The definite integrals?
You're going to have to use definite integrals. Again, you're going to have to use your fundamental theorem of calculus. So it's going to be 71. Let's make that 71. 71 plus the integral from 20 to 30 w prime of t dt. At time a, 71 plus the integral from 20 to a w prime of t dt. Yeah.
That's 71. There's a dimension. 30.
Wait, one more time.
How is that 71? There's a dimension. 30.
Because they told you back in the beginning. Right, so I'm using this table of values to say I know what the temperature of the water is at 20 degrees. Okay, Brian?
So the WT is a function in, oh wait, never mind.
Oh, yeah.
We're okay?
Yeah, that.
Okay, so now it's just gonna be a matter of doing some computations with your calculators that no one seems to even be touching. Okay, so I'm just gonna assume that we are okay at this point.
Just practicing.
Are all the friends okay?
My calculation.
Oh, for the
Right.
relative max, I
Yeah.
thought it was W prime of T changed from increasing to decreasing.
Okay, so where W has a relative max, that would mean sort of like the middle here is that W is changing from increasing to decreasing. But W prime changes positive to negative.
Oh, okay.
Okay?
Alright.
I would for sure add on F prime, F double prime relationships as something to study this week.
Yeah.
Okay? All right, you guys all right? Okay, so here's what I'm going to encourage you to do. I want you to find a new partner to work with for the next 15 minutes. We're going to turn Roger off. Bye, Roger.
Adios.
Adios.
And the camera.
Don't get rid
Oh, wait, you haven't turned him off yet. Roger. Hi, it's me, your calculus teacher. All right, so what I want you guys to work on for the next 15 minutes is this 2011 AP exam question number 2. It's known as the tea and biscuits question. I'm really interested to see what you guys can do with this problem. And homework this weekend. This is an optional homework assignment. Don't stop listening, Nathan. Okay? Don't pull, let's call it an Alejandro.
What?
Here's the homework this weekend. You have 1, 2, 3 free response questions. If you do 2 of the 3 fully, all the parts, skipping nada, I will excuse your lowest homework assignment grade, even if it's one that you didn't do. If you do all 3, I will drop your 2 lowest homework assignment grades, even if it's 2 that you didn't do. Nathan's jotting it down. He's like, do these. These are due in class on Monday. You do not have to give them to me before Monday, okay? Or like Monday at 8 a.m. or any of that nonsense.
What is our lowest grade?
What? Honestly, on Monday, I'm not even going to grade this. I'm going to go over this. Like, did you do all the work? Does it look good? Great. Let me excuse the lowest homework assignment grade. You did all 3. I'll excuse the 2 lowest homework assignment grades. That's the plan. Okay? Now we can say goodbye to Roger. Bye, Roger.
Don't get rid of
Okay, you guys have 15